Assalamualaikum warahmatullahi wabarakatuh, and very good day I bid to Dr. Eris and also Dr. Ujila. Today we would like to present about our project, our group project. We are from group 18 of class EMM3218 heat transfer application. First of all, I would like to introduce the group member. The first one is Jivan, entry number 197-188, Ravi Shankar 197-260, and me myself, Muhammad Iqmal bin Masa'ad, matric number 198725. First of all, I would like to continue for the introduction. For the introduction, the heat transfer is a process of transfer the heat from the high temperature to the low temperature. Basically, the definition is refer to the definition of the conduction. As for the daily application that we will be conducted is for the daily application, it is about the housework, where the sunlight or the heat source is come from the sunlight itself, and for the industrial application is the boiler in steam engine that have been applied in the textile industry. For the for the housework, the heat transfer that has been conducted in the housework is from the radiation that included in the house wall is the radiation and also the conduction. The radiation is happen when the solar is come into contact into the outer surface of the wall, and then the radiation and then the outer surface will be heated up, and then the conduction will be happen that from the outer surface that have from the outer surface brick that have a hot temperature will be transferred to a inner surface of the wall that have low temperature. That's the application for the house wall. For the further application, for the further explanation will be present or explained by Jivan. Next, for the boiler and steam engine that have been used in the textile industry. Basically, this boiler and steam engine for the textile industry is used for that they will be set up the boiler to a certain temperature that to heat up a dye to get a desired color for the dye for the textile itself. For the heat transfer or heat transfer concept that are applied in this area is the radiation and also the conduction. The radiation is come from the furnace. As you can see, the furnace will be heat up the water in the boiler. Will be heat up the water in the boiler. Then the boiler will the conduction will be happen from the surface that have a high temperature to the low temperature that where the steam will be out from the boiler itself. For the further explanation of the boiler and steam engine will be explained by Ravi Shankar.
Hello, my name is Elianddy and my matric number is 197-188. Today, I would like to talk about heat transfer in household. Okay, now we're going to discuss about the detail that involves in the heat conduction through a plane wall. So, as you guys can see, this temperature one in out of the wall and temperature 2 in the wall. As you can see, in the wall means it's in the house. So there is temperature difference between this, and the temperature only moves in x direction. So we're going to see about the step 1. Step 1, in order to solve this kind of problem, we need to actually write a general heat conduction equation first, which is this. And step 2, you need to use the conditions just like the first condition, steady state. Steady state means temperature does not change with the time. So the delta T over delta tau is equals to 0. And the second condition, one dimension, so the x plane and the y plane is will be considered to 0. So there is the third condition is there is no internal heat generation. So the Qg over K is also equals to 0. So second, as if we use all these conditions to this general heat conduction equation, we will get the delta square T over delta x square equals to 0. So we need to integrate this. So the step 3 is integrating it. As you can see, delta square over T over delta x over square equals to 0. So if we integrate that, again, we will get C1, and if we integrate it to T, we will get C1x plus C2. And second, we will use the boundary condition in order to get this in T2 in T term. So first, x equals to 0, T equals to T1. So, and x equals to L. L is the thickness of the wall, and T is equals to T2. So by doing this, we will get C2 equals to C1, and C1 equals to T2 minus T1 over L. Okay, if we substitute this equation in this, we will get T equals to T2 minus T1 over L, x times by x, as you can see this, the C1x, x plus T1. So the fifth step is using the Fourier equation. The Fourier equation says that heat loss is equals to negative K over A times with dt over dx. So if we use this, we will get if we replace the dt over dx in previous C1, we will get the T1 minus T2 over L. So the step 6 is using the thermal resistance in order to get the heat loss. Thermal resistance conduction equals to L. L is the thickness, and K is conductivity, thermal conductivity. A is the area. And we will get this formula, Q equals to T1 minus T2 over thermal resistance. Okay, for the case study, we will be looking at an example or situation. And first, I'm going to explain about the situation. The wall of the house in cold region comprises 3 layers, which is 15 centimeter outer brickwork and 1.25 centimeter inner wooden paneling and 7.5 cm intermediate layer of insulating material. The insulation layer is stated to offer resistance twice the thermal resistance of the brickwork if the inside and outside temperature of the composite wall is 20 degrees Celsius and negative 15 degrees Celsius respectively. Determine the rate of the heat loss per unit area of the wall and the thermal conductivity of insulating material. And for the solution, first we are going to identify the what we got. So the thermal resistance of the plane is wall of the thickness, which is equal to L, and the area is A, and thermal conductivity is K. And as we all seen before, the thermal resistance of the thermal resistance equation is L over K over A, K times A, and this is the resistance that we obtained. And for the brickwork, 0.2, and for the wooden paneling, we get 0.0625, and for insulating material we get 0.4, and for the total resistance we plus all this and we get 0.6625 degree. Okay, for the heat loss, as we know the equation, delta T over difference with T difference and total resistance, and we get 52.83 volt. And for the thermal conductivity of the insulating material, L over A times thermal resistance, and we got 0.1875.
So today I'm going to explain about one heat exchanger application in industry. So before we go to the topic, what is a heat exchanger? Heat exchanger is a device which transfer heat from one medium to another medium, which are from different temperature background. So there are many heat exchangers that currently used in the industries. We are going to see about the steam boiler. So what is a steam boiler? Steam boiler is a container that heated water to produce the steam, which will be used for other processes. Steam boiler is widely used at textile industry since since the steam is used for fiber production, weaving, dyeing, drying, printing, and heating the equipments and maintaining the temperature of the system, uh, they are using the steam boiler to produce the steam. So textile manufacturing also require a quick steam solution that can water efficiently on 265 degree Fahrenheit, so for dyeing the other textile manufacturing processes. So there are two types of steam boilers. First one is fire tube boilers. Second one is water tube boilers. In fire tube boilers, they use gas as the main, and in water tube boiler, they uses water as the main material. So in textile industry, water tube boiler is widely used since it can produce larger steam compared to the fire tube boiler. So you guys can see the image of the water tube boiler, how it's arranged. The tubes that contain water is surrounded by the hot gases, so the heat will be transferred to the tubes, and then the hot steam will be released to the external pipe. So there are several heat concepts that involve in the steam boiler. There are three, which is radiation, convection, and contraction. First, we are going to see about the radiation, how the radiation is happening in the steam boiler. So if you guys see at the image shown, the heat is generated from the burning of the coal, which will be spread to the tubes that contain water in the form of electromagnetic waves. So when these electromagnetic waves come in contact with the tubes and other areas, the tubes will absorb the heat. So this is called as the radiation. So when the burning of the coal, there are some flue gases which will be generated. It also will be absorbed by the tubes. So next is the conduction. As we know, conduction will be caused by the free electrons that transfer heat from one body to another body. So if we can see the innermost in outermost of the tubes will be heat from the radiation, and as the innermost part of the tube also will be heated. So thus the heat will be transferred into the water in the tubes. This is called as the conduction. So for the calculation parts, they are mainly in steam boilers. They are mainly calculate about the heat losses due to radiation, heat losses from the furnace by the flue gases, and heat losses from the hashes, and heat loss from the moisture of fuel and air, and then the heat loss from the surface. This is the basic heat losses that will be calculated in the steam boiler. The steam boiler efficiency is calculated by the formula heat output from the steam and heat input from the fuel times by 100.
Okay, for the conclusion, heat transfer is very important that have been applied in our daily life, such as in the making of food, glass manufacturing, and also and etc. In the making of food, uh, the heat transfer that being applied is the conduction. And heat transfer is also important in order to indicate the material selection, the machine efficiency, and also the kinetic reaction that have been used, that have been applied in the machine itself. It is important to know the material selection for a certain machine or system so that the system will become a good efficiency. Okay, I think that's all from our group. Thank you.